Welcome again to the Forest stage. I'd like to introduce to you Marina Guryeva of Neon Labs. Please come on up. Thank you so much for joining us.
Thank you.
Okay.
Oops. I will try to put this bottle first. Hi, everybody. It's a pleasure to be here. Thank you for having me. And I would love today to present you the Neon EVM solution and basically to go through the tech challenges that we encountered while building EVM on Solana. So, but first, I assume that most of you, you are from Ethereum ecosystem and you know perfectly well how Ethereum works, how smart contracts are built, and then how Ethereum transactions looks like, etc. So for you, Ethereum ecosystem is like the Milky Way that you can see here. So it's a galaxy familiar to you. But then the next picture that you can see on this slide, it's the galaxy NGC 474, which you probably don't know, but then it's elliptic galaxy, which lies 100 million light years away from the constellation of the Fish. And this is, I assume, what Solana is for you. And first, I have to explain you a little bit about Solana, because Solana differs a lot from Ethereum. And in order for you to understand better what we have done, you have to understand what Solana is. And basically, this is the standard Solana program, and you can compare Solana ecosystem with the operating system. Basically, you have programs within it, and you have data accounts. Like normally, what you have on your computer, you have, for example, Adobe application, and then you have files, PDF files. And so with the Solana, you have the similar things. So you have special Solana programs which execute basically the data. And then you have the special Solana data accounts with the so-called program-derived addresses. And these addresses, they don't have public or private keys, and so they can be executed only by Solana programs, so they can't launch any transactions by themselves. And this is a crucial thing to understand. So this is how Neon EVM looks like within Solana ecosystem. So Neon EVM is a smart contract, Solana smart contract. So it's a program written for Solana. And what we have here, we have Neon DAO, which owns this program, and then we have Ethereum virtual machine bytecode within the data field of this program. And definitely we have to have a true in order for this program to be executed within Solana ecosystem. What we have also, we have a set of Solana accounts, and we have different type of Solana accounts. First of all, we have Neon accounts, which is similar to Ethereum accounts. So within the data field, we have all the information relevant to Ethereum accounts. And within the Neon contracts, it's a special type of the other type, better to say, of Solana accounts. We have Ethereum smart contracts. So we have within the data field all the information relevant to any Ethereum smart contracts. And we definitely have another set of accounts, Neon contract data accounts, which are connected to these Neon contracts, basically Ethereum-like smart contracts. And this is the structure that we had to build in order to enable the operation of the EVM within Solana ecosystem. But then we still have to pack the Neon transactions, which are Ethereum-like transactions, into Solana transactions for them to be executed correctly by Solana on Solana nodes. So what we do, we put the crucial information into different fields of the Solana transaction. Within the program index field, we put in the information to the Neon EVM program, which has to execute this transaction. Then within the account list field, we put all the accounts associated with the particular transaction. And this is important, crucial. And within data field, we put all the relevant Ethereum, all the relevant to the Ethereum-like transaction information. Basically, familiar to information, nonce, gas price, gas limit, everything else, they are put within this particular field within Solana transaction that we form. So, and then the magic happens, so to say. We have Ethereum dApps running and being deployed on Neon EVM. They send Neon transactions, which are Ethereum-like transactions, but then they send them to a special tool, which we call Neon Proxy Server. Because we have, as mentioned already, somehow wrap these Neon transactions into Solana transactions in a way that I mentioned before, and then send to Solana transactions, as Solana deals only with Solana transactions. So, and here you can see how Neon Proxy works. What is more important, as mentioned already, we have somehow to get information about all the accounts relevant to the particular Neon transaction. And somehow this Neon proxy has to figure out which accounts are associated with this particular Neon transaction. So we have here an emulator. Basically, Neon proxy emulates the execution of the Neon transactions using the off-chain Neon EVM which connected to the Solana accounts on Solana nodes. And so it gets all the relevant information which it puts to the Solana transaction and sends the Solana transactions forward to the Solana nodes. And then magic happens, because you know Solana can execute transactions in parallel. And so while we deal with the Solana transactions, the parallel executions happens naturally, so to say. Solana nodes, they get a list of Solana transactions, and so they call Neon EVM as a program, and then a Neon EVM calls the relevant Ethereum programs, the execution happens. So it is done in parallel because of the structure that we have and the architecture that we have. However, you might know that Ethereum transactions, they can be very, very long indeed. As for Solana transactions, they are limited to the number of the BPF cycles. So we just sometimes can't wrap one Neon transaction into one Solana transactions. We have to split big Neon transactions into several Solana transactions, but then they still represent one Neon transaction, which means for us one Ethereum-like transaction. So, and as far as I remember, so one Solana transactions can contain about 750 opcos, Ethereum opcos. So what we do, we split the Neon transaction into several Solana transactions. Proxy does this work. And then we have iterative execution of Neon transactions. So somehow we have to execute each and every Solana transaction, which corresponds to the one Ethereum transaction. And we use a special Solana storage account for these purposes. Basically, what we have created, we created a special infrastructure where we keep the intermediate information while the execution of these intermediate Solana transactions happens. So, because the Solana state has to be written and updated on the last step. So we definitely want this transaction to be seen as one transaction by Solana. So when the first step happens, so Neon EVM blocks the accounts that we have in this particular Solana transaction, then it executes whatever it has to execute, and then it reads the data from the special Solana storage account that we have, and afterwards it saves the EVM state and sends the information back to Proxy, and Proxy sends the next Solana transaction associated with this particular Neon transaction. The thing repeats, and on the last step, it changes because the information that is being updated is updated on Solana state, not within this particular and special Solana storage account that we have, but then as it is the last step, we update all the accounts on Solana state, and we unblock all the accounts, and we send the receipt to the proxy that one particular Neon transaction is completed. So, how to ensure atomic execution of the Neon transaction? Basically, we have these because we have we block the accounts at the beginning, then we unblock the accounts at the end, and we update the state of Solana on the last step only. What happens when we have, for example, a second Neon transaction running in parallel? So proxy sends the Solana transaction to Solana, and Solana checks during the first step whether accounts are blocked or not. And if it finds that the accounts are blocked, then the execution fails, so nothing can change the state within the execution of this first Neon transaction. But then the architecture that we have implemented already doesn't allow us to run in parallel the transactions within the same contracts. And this is a problem. So, and we want to resolve it because we would rather prefer all the transactions to be executed in parallel in order to use the what Solana, the advantages that Solana has. So, and we have a plan for the optimistic parallel execution of Neon transactions. And basically, this is the architecture that can be used not only by us, but then we think that it might be applicable to other EVMs as well. So what we want to do, we would rather prefer not to block the accounts associated with the first Neon transaction at the beginning, but then to check the state during the stages, during the execution of this particular Neon transaction on different steps. So, and if we have some changes within the state, for example, here you can see on step third that we have value 2, not a change within the value 2. So we have to go back to the stage where we first encountered this particular variable, and we have to do it again because somehow in parallel something happened and the data were changed. So, and this is the solution that we really would love to discuss with the Ethereum crowd, and we really would love to test, and if you're interested in working with us on it, you're welcome. Just please join us, our channels, our dev channel, especially on Discord. So this is something that we would rather prefer to discuss with you and to implement together, not only within Neon EVM on Solana, but also on other EVMs on different chains. And this is it. Thank you for your attention. So if you have any questions, I would be more than happy to answer them, but please. Yes, please. I don't know how it works with the mics, so.
Hello, thank you very much for your presentation. This conference, we have seen Polkadot presenting the Moonbeam EVM. We've seen Near presenting the Aurora. Now you present Neon. This is the surrender of the alternatives to the Ethereum virtual machine. I mean, as a developer, how we need to handle this news you give us? Is that you no longer want to make Solana an independent development platform? You want everybody to go to EVM? What's your vision of how the development in the Web3 will evolve?
Thank you for your question. So definitely, we all have a lot of these solutions because EVM is basically Ethereum ecosystem is the biggest ecosystem, and there is a demand from the Ethereum dApps in terms of the please give us a new market. So we are ready to go anywhere where users are, but then we need to go there natively. So we don't want, for example, we don't want to build anything on Solana using Rust from scratch, because it will be a totally different program. So we want to port over our contracts somehow to Solana and use them there in order to tap into new market. And this is what we have. So and this is what we work with. Basically, this is the demand, and for us it's crucial not to build yet another EVM ecosystem on Solana blockchain in our case, but then we really want to just to enable the smooth porting of the contracts for one hand, but then we want give the developers the interoperability between Neon EVM ecosystem on Solana and Solana ecosystem. Basically, this is what they are asking for, and it's the next step that we will do, because it's not that easy as you might know, to enable interoperability between Solana and Neon EVM itself, but then it's something that is in demand, and what we will do. So for us, it's okay. So these are the market on Solana. The guys want to tap into this market. We have to provide the tools for them.
Thank you.
Hi, hello. I thought I heard at the beginning, but I might have been confused, that there's some off-chain centralized servers doing that do some tasks related to the EVM, or did I misunderstood?
No. There is nothing here that is centralized. So the proxy servers, they can be run by anybody. So the tool that basically emulates the execution and wraps the Neon transactions into Solana transactions, this tool can be run by anybody. If you want, you can. So first, we will start with some preset of operators, but then it's a job to be done for the market. So it's decentralized. In terms of how the emulation is done, I mentioned that proxy uses off-chain right now, off-chain EVM that is connected to the Solana accounts on Solana blockchain. But this is something that is we're still on Solana DevNet, so it will be changed going forward. But right now, the proxy works like this. So. More questions? I don't see anybody. Do you? Okay, then thank you very much.